Hello there, welcome to this video where we'll be talking about the derivation process of the future value annuity formula. Now, annuities are fixed payments that are made over time but at regular intervals. It can be monthly, it can be yearly, it can be quarterly, depending on the nominal basis that one is working with. Now, when one looks at the future value annuity, that is based on investments. This is when one wants to determine the future value of putting away a certain amount of money at regular intervals. Okay, so here is the formula, and I believe you know the meaning of the variables so far. You can just recap. X stands for the regular payment that will be made. I, of course, is your interest rate, and N is the number of payments that will be made over the period of time as depicted by the timeline. Okay, so here's a timeline. Let's put in some more details from T0 to Tn. So you make your first payment there called X. The second payment comes in there. Third payment, second last payment. You go with the third last payment, second last payment, and then your last payment comes in there. Okay, notice that your last payment will not accumulate interest, but your second last payment will accumulate interest for one payment period. Okay, and your third last will accumulate interest for two payment periods, and this one, that payment that you make in this financial period or financial cycle will be n-3. Okay, so the distance from T3 to Tn is definitely n-3, and this one will be n-2, and that one will be n-1. Okay, so to now get the sum, which will represent the total value in the future that we will then obtain, we can write it out mathematically like this. Okay, so X at T1 will accumulate interest, okay, for n-1 times, or can be n-1 months or quarters, but remember this n is really payments. Okay, plus T2 x 1 plus I to the power n-2, T3 x 1 plus I power n-3, plus x and Tn-2 now, 1 plus I to the power 2 plus x, 1 plus I to the power 1 plus x, and that is the last payment that comes in. Now notice we have written this summation or this series in descending powers of x. Let us just rewrite it in ascending powers of x and observe something. X plus x1 plus I plus x1 plus I square plus, okay, should actually be an ellipsis there. Okay, x 1 plus I power n-3 plus x 1 plus I to the power n-2 plus x 1 plus I to the power n-1. Okay, well, this is a series in exponential form, brings to mind a geometric series, and we can test that. We have a constant ratio, T2 divided by T1 is 1 plus I. T3 divided by T2 is 1 plus I. So our constant ratio is 1 plus I. And if you want the sum of a finite geometric series, you have the formula Sn is equal to A r to the power n minus 1 over r minus 1 with the restriction r is not equal to 1. Okay, so let's substitute. We have a being our x, and r, 1 plus I to the power n minus 1 over r, 1 plus I minus 1, and the cancellation there happens, and this now is reduced to x into 1 plus I to the power n minus 1 over I, and that represents the future value annuity formula. And really that takes care of the derivation process, and I hope this was helpful and valuable, and you will now apply it with an informed knowledge as to where it comes from. Okay, thank you for tuning in. I'll see you in the next video where I'll be talking about the present value annuity formula. See you there.